Hi everyone, myself Rekha, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. So today we are going to see the topic queuing theory and the resource management technique. So this course is very useful for the BBA, BBA CA and as well as for BCom PA students. So this is from Unit 3, you make use of it. So we are going to see the Model 3, that is M/M/1 NFIFO. Normally, queuing theory, we can say it is a waiting line of a customer. So, the examples of some of the queues means we used to wait in train to buy the tickets and as well as in supermarket and telephone booth or else in barber salon. So, the customer arrives at a service facilities. So, not only in that, we used to wait in the bank also. So, nowadays we are applying the queuing in the online to buy tickets, everything. If you want to buy a cinema tickets and all, we are used to wait in the online. So wherever if you go, you have to wait. So there will be different types of models in the queue. So for that, first we have to know what are the basic definitions in the queue. So you have to know what is customer, queue, then arrival distribution. So customer is nothing but arrival pattern. We used to say it is a customer. So what is mean by queue? With the number of customer waiting to be served, we can say it is a queue. Arrival pattern is nothing but a person entering into the system. We used to see as a arrival pattern. The arrival of customer is defined as arrival time and the number of customer entering per unit time. We used to say. And also service in random. So service in random means the customer used to serve by a servicer. So the departure of the customer depends upon their service time. So we have some of the queue disciplines are there, that is first in first out, last in first out, that is service in the random, and as well as we will use to give a priority for some of the VIP during the queue. So these are the basic definitions for the queue system. But we are going to see the model 3, that is M/M/1 NFIFO. In previous video we have discussed about the M/M/1, that is infinity FIFO. So this represents that queue system is not only the one model, we have 2-3 models and all. So based on the number of customers acquired in the system, we used to say it is a model 3. In this only finite number of customers only allowed. Okay. So let us see one problem for that model 3. If a period for 2 hours in a day, the train arrives at a yard and every 20 minutes and the service time continues to remain 36 minutes. The probability that the yard is empty. The average number of trains in the system on the queue, that the line capacity of the yard is 4 trains. So we used to say that the limited trains is n equal to 4. So we have an arrival pattern and as well as the service times in random. Normally arrival pattern we used to represent it as lambda, whereas the service is represented as a mu. So in previous problem we have told that the arrival pattern is nothing but how many arrival at the yard 20 minutes a day and whereas in 36 minutes. So lambda can be calculated as 36 for one train. So 1 by 36. Okay. So 1 by 36, whereas mu is nothing but 1 by 36. Rho equal to 1 by 20 by 1 by 30. So you got a value as 1.5. Now we are going to calculate that how many probability that the yard is empty. So for this problem we have to find the formula P naught, P minus 1 slash P power n plus 1 minus 1. P is nothing but 1.8. So 1.8 minus 1 divided by 1.8 whole to the power of 4 plus 1. 4 plus 1 is nothing but 5. So 5 minus 1. So you will get, if you raise the power, you will get 18.895 minus 1. So 17.895. And similarly, we are going to find the expected E of n, that is how many number of trains you are waiting, 4 trains. So you have to raise the power up to 4. So P naught into 0 into P naught plus 1 into P1 plus 2 into P2, 3 into P square plus 4 into P power 1. We already got the value of P is 1.5, so we have to multiply 0 into 1.5, 1 into 1.5, 2 into 1.8 the whole square plus 3 into 1.8 the whole cube. So if you multiply this value and using the calculator, you have to find the value for 1.8 square and 1.8 cube. You will get 10.493. Adding all the values, you will get 67.748. So multiplying this to you will get 3.102. So approximately we can, the expected number of trains we can say that it is 3 trains, because the second question is we have to find the average number of trains in the system. Okay, so thank you students. So next video we can see the what is mean by queuing theory, and also we have discussed the remaining problems also, okay, in the model 3. Thank you, Pa.